and welcome back to my channel. This is episode number 8 of the Glaciated Landscapes and Change series over on my channel. I have done all of them up till now. I'll link the playlist up here for you. There's also a full playlist of tectonic processes and hazards all in this playlist. I'd recommend you go and watch them if you want to know more about this, or if you're a geography student, please share it with someone you know. Today we're going to be looking at glacial erosion and landforms, and I hope you learned something. I'm Lara, if you don't know. I'm a second year geography and education student at Liverpool Hope, and I'm making these because it's exactly what I needed while I was doing my A-levels. I studied the EdXL specification, EdXL-B to be more specific, and this is exactly what I wanted and needed whilst I was doing my A-levels. So I hope it's helpful to some of you guys too. And if it is, please like, subscribe down below. I make these every single Monday, 4:30 PM. They go up on my channel. And yeah, without further ado, let's just get straight on into this video. What is a glacially eroded landscape? This picture was taken close to the summit of Hevelin in the Lake District. This photo is looking roughly east or northeast over one of the most iconic glaciated landscapes in the UK. The steep ridges, bare rocky outcrops, lakes and wide valleys are typical of a glacially eroded landscape. We touched on this last time, but there are two types of glacial erosion: abrasion and plucking. Abrasion is the sandpapering effect of ice as it grinds over and scours a landscape. It happens because freeze-thaw weathering creates sharp fragments that become trapped under the ice. They become extremely abrasive tools. Large rocks carried beneath the ice often scratch the bedrock to form striations. These scratches provide useful clues for scientists studying the direction of ice flow in a post-glacial environment. Over time, these rocks become pulverized by the weight of the ice and become a fine rock flour. This finer material then tends to smooth and polish the underlying bedrock. Plucking or quarrying occurs when basal meltwater freezes around a part of the underlying bedrock at the base of a glacier. Any loosened rock fragments are plucked away, giving it its name, as the glacier subsequently slips forward. It's a bit like pulling out a loose tooth. This process is particularly common where localized reduction of pressure under the ice has led to regulation, the refreezing of meltwater. In addition, the weight and pressure caused by the thick ice can be sufficient to crush the surface of the poorly jointed bedrock. How glacially eroded landforms develop. A number of different erosional landforms associated with cirque and valley glaciers. Cirque glaciers, or corrie glaciers, are small masses of ice that occupy arm-shaped chairs hollows in mountains. They often overspill from the hollows to feed valley glaciers. Valley glaciers are the larger masses of ice that move down from either an ice field or a cirque. They usually follow former river courses and are bounded by steep sides. A corrie, also known as a cirque in France or a coombe in Wales, is an enlarged, often deep hollow on a mountainside. Its characteristic features include a steep cliff-like back wall, often with a large pile of scree at its base. There's also usually a raised rock lip at the front of the hollow, which acts like a dam to trap water and form a small lake known as a tarn. To understand how a corrie develops, we need to look at the processes at work before, during and after glaciation. So in periglacial conditions, this is when we're on the outskirts of a permafrost area. Periglacial processes, particularly those associated with snow, nivation, and frost and ice, slowly increase on the side of a hollow or depression in the mountainside. Glacial conditions. As the climate cools, snow turns into ice on the depression and the corrie glacier develops. Accumulation at the top of the glacier increases its mass, and rotational sliding results in a scooping out of the hollow. This is called rotational slip, and this scoops out the hollow through abrasion. And then post-glacial conditions. As the climate warms, first periglacial and then temperate processes, including frost and water action, modify and shape the corrie to what we see today. Corrie orientation. In Britain, as elsewhere in the Northern Hemisphere, corries are nearly always orientated northwest through to the northeast. This is where the frequency peaks to the southeast at 135 degrees. This is because in the UK, northern slopes receive much less solar insulation, so glaciers on those slopes last much longer than those facing more southerly directions, where more sun meant faster glacial melting. Western slopes often face the sea, and although still cold, the relatively warmer winds which blow from that direction were better at melting snow and ice, so more accumulated on eastern facing slopes. And the prevailing westerly wind in the UK causes snow to drift into east-facing hollows. Arêtes and pyramidal peaks. When two neighbouring glaciers cut back into a mountainside, the narrow knife-edged ridge that forms between the two corries is known as an arête. Arêtes are common in both present-day glacial landscapes such as the Alps and in post-glacial landscapes such as the Lake District. Where three or more corries erode back to back, the ridge becomes an isolated peak known as a pyramidal peak. It looks quite pyramidal, to be fair. Glacial troughs. Glaciers are immensely powerful agents of erosion. They can be several hundred metres thick, and their vast mass enables them to create spectacular and dramatic landscapes. The Athabasca Glacier is shrinking, and as it does so, more and more of its impressive valley is being revealed. Glacial troughs are characteristically steep-sided, mainly flat-bottomed and deep, often several hundred metres deep. They tend to be largely straight because of the power and inflexibility of the glaciers that erode them. The main process of erosion is abrasion through basal slip. Plucking does take place, but more selectively than abrasion. Glacial troughs may contain deep, narrow lakes called ribbon lakes. These result from localised over-deepening due to enhanced erosion caused by the weaker bedrock, allowing increased vertical erosion, the merging of a tributary glacier which can lead to greater erosion of the valley floor due to the increased ice mass, or a narrowing of the valley and the resulting of thicker ice, which leads to increased vertical erosion. Hanging valleys. As a small glacier in a tributary valley doesn't have the same mass as a larger glacier, so it won't be able to erode down as far as the large glacier. When the ice melts, the smaller valley is left hanging above the main valley glacier as a hanging valley. Truncated spurs. In a typical upland river valley, the river flows around the interlocking spurs of rock. However, when a valley is occupied by ice, the rigid, more powerful glacier cuts off or truncates the tips of these rocky spurs as it moves downhill, leaving behind steep cliffs called truncated spurs. Although abrasion is the dominant focus in the formation of truncated spurs, plucking also takes place on the bare rocky surfaces. Sub-aerial processes, so from above, such as frost shattering, freeze-thaw weathering, and rock falls, which is a type of mass movement, also act on the exposed rocky cliffs protruding above the ice. This picture shows Greenland's Watkins Range mountains. Enormous glaciers are currently sculpting the landscape to form several of the landforms described previously. Notice how the truncated spurs tend to form between the hanging valleys. The formation of landforms due to ice sheet scouring. Crag and tail. The underlying geology plays a part in the formation of crag and tail landforms. Crag and tail is when a very large resistant object, or crag, obstructs the flow of a glacier, such as the basalt volcanic plug on which Edinburgh Castle sits. The ice is forced around the obstruction, eroding weaker rock. However, material immediately in the lee of the obstruction is protected by the crag, which leads to the formation of a gently sloping tail of deposited material. Roches-Matonnées. Roches-Matonnées are the bare outcrops of rock on the valley floor that were sculpted by moving ice. They demonstrate two processes of glacial erosion: abrasion and plucking. The upstream side. Increased pressure due to the resistance of the outcrop to moving ice caused localised pressure melting. This led to basal slip and abrasion as the glacier slid over the outcrop. The abraded upstream side shows polishing and striations. The downstream side, however, reduced pressure caused meltwater or freeze, forming a bond between the rocky outcrop and the overlying glacier. As the glacier moved forward, it plucked away loose rock, leaving a jagged surface. Knock and Loken landscapes. This is the name given to glacially scoured lowland area, which has alternating roche montagnes and eroded hollows, which often contains small lakes. These landscapes are often closely linked to rock structure, along features such as joint and minor faults. They are mostly found where alternate, resistant and weakly jointed rocks allow for differential erosion. That is the end of episode number 8, I think we're on. I hope you're enjoying this series so far. Please subscribe down below. I make these every single week and I will be doing until I get through the whole of the specification that I studied, and I might continue with it depending on like the results, whether you guys like it, whether you guys are doing a different subject to me, that kind of thing. Anyway, thank you so much for watching. I hope you enjoyed. Please like, subscribe down below, and I'll link the playlist up here of the other geography videos that I've done if you haven't seen them. Please share this around. The more the merrier. Hopefully we can all make geography slightly easier for everyone, and if you don't get on with your teacher, don't send this to them because they might see it, but if you don't get on with your teacher, hopefully I can teach you something, yeah, to help you do well in your A-levels. So yeah, thank you so much. I will see you same time, same place next week. Bye guys.